All right, solving similar triangles. The way I taught it on the last lesson with congruent and similar triangles may have seemed like similar triangles was just super easy. Well, it is, actually. I don't have something really difficult coming here, but there's a little tiny bit more to the story. The good news is they're very repetitive. Doing similar triangles in grade 10 is very repetitive. If you understand what I'm doing here, you're going to be like, oh yeah, and you can zip through the homework. It won't be a problem. And the assignment, yes? Many people, similar triangles is their favorite part of this course. It just speaks to them. They just go, I totally get what's happening here. Oh yeah, for sure. Anybody else need to know why I'm holding one right here? All right. So our learning goal. I will be able to solve for different measures using similar triangles. Maybe you think you already can. But there's a little more to the story. Okay, recall from last lesson. Similar triangles have equal angles. All the angles will still be equal. Remember what happened. You take a triangle and you basically use your photocopier to blow it up into a bigger triangle. It's like taking a picture. Let's say you're at the Rogers Center downtown Toronto and you took a picture of something. The picture on your screen wouldn't be as big as the Rogers Center, but the angles would all be the same. All the sides would just have changed length. That's what similar is all about. It's a photograph of what you're talking about, but to scale, yes? And then proportionate corresponding side lengths. It's okay right now if you're like, I'm not even sure what proportionate means. That's really what I'm going to explain today. What does proportionate mean? So a proportion says that two ratios are equal. Now listen, when you first show this to grade 3 people and say this is the same fraction as this, they're very upset. They're like, it is not the same. And I sort of agree with them. It's not the same, but it has the same value. Yes? It's proportionate. I doubled everything, so it's the same proportion. 1 yellow for every 2 purples is the same as 2 yellows for every 4 purples. Hopefully you really know what that means. But again, maybe you didn't have the word just right at your fingertips until now. That's proportionate, when 2 fractions have equal value. The same? Well, we could argue whether they're the same. We sort of act like they are the same fraction, but we could argue about that. But proportional means maybe they're not the same, but they're proportional. So we can see 1 out of 3 is equal to 2 out of 6 for our purposes. The ratios are the same, so they're in proportion. This really relates to similar triangles. When things are in proportion, their relative sizes are the same. Boring slide. Hopefully boring slide. New algebraic weapon coming. Well, it's not that new. It's not that exciting. Here's what I'm going to do. Here's your job, all right? I'm going to do this question using the weapons you already have. And by the end, I hope somebody can come up with a shortcut to it, all right? So you watch my steps, and then at the end, you come up with the shortcut. The shortcut at the end. You already have the shortcut? He already has the shortcut. All right. That's boring. All right, you're bored with what I'm about to do then, yes? Okay, my job, do this using the weapons I've already taught you this semester, and then at the end, a shortcut. I look at this and I go, x over 5 equals 4 over 10. I'm very upset about the fractions when I see them, so I go, to get rid of the fractions, the left side is divide by 5. I'm going to get rid of that by moving it over to the other side and multiply by 5. So this becomes x equals 4 over 10 and then multiplied by 5. Now, if you're really on the case, you're like, well, aren't I done there already? I'm like, yes, but sometimes the unknown's in the denominator. So I'm just going to keep going and show you a little more about this situation. Maybe you're still upset about the fractions because this side's divided by 10. So I take the divided by 10 and I move it over to the left side where it becomes multiplied by 10. And aren't you happy at that moment? You should be very happy because it's like, oh, that got rid of the fractions. By moving the divide by 10 from the right to the left and make it multiply by 10, and moving the divide by 5 to the right and making it multiply by 5, I have an expression with no fractions that will be very good at solving, I hope. I hope we're like, oh yeah, I got it from here. In a second, I'm going to finish this question, but in a second, I'm going to ask someone to come up with a shortcut from here that you can use or not use. Some people really like it, okay? You still on the case? You still got the shortcut? Let's see, 10x equals 4 times 5 is 20. and then I divide both sides by 10, and I get x equals 2. We're going to use this set of steps a lot over the next few weeks, not just the next couple of days. How do we solve a proportion? We multiply each side by the other denominator. Yeah? So now how do you have the shortcut here? And the name for it, do you have it? Oh, yes. Yeah, that is another way to do it. I have no problem with doing that at all. As you say, what's the multiplier here? I took 5 and I multiplied by 2 to get 10, so I've got to divide by 2 to get there. It can be a little confusing to do it that way sometimes, depending on where the unknowns are and depending where the decimals are. See, right now, in just a second, these are all going to be decimals. So that can get a little, like right here, you can see, oh, it's multiplied by 2. So when they're nice like that, you should definitely do it that way. Good. I like that way. I know what she's saying. A different way.
Cross multiplication.
She's got the word, and I'm not, that's surprising because I don't think we really teach it, cross multiplying, before this grade. So it's, I'm going to ask her later how she knows that word so easily. But have you heard it before, cross multiply? Oh, maybe you did it in the new grade 9 course. Okay, so that's fine. Cross multiply. I haven't taught the new grade 9 course, so I didn't know that maybe you'd seen that before. Cross multiply. It's a little tiny bit dangerous because it's only cross multiply. I made my students always say it. Cross multiply across an equal sign. We don't just cross multiply any two fractions we come along. It only works if you're going across an equal sign. So I actually used to make when I used to teach this in lower grades, I'd go like this. Put those arrows on there. That's when cross multiply works. It's not just a rule you can use anywhere. Very handy to very quickly do proportions. Okay? So on this one, I will do the cross multiplying on this one and show you how easy it is. And then I'll get you to try the next two. Hopefully you won't be mystified by the next two, but I'll talk about them. So here's how I think you should do cross multiply. You go, okay, an arrow that way and go 12x. Notice I went after the variable first. You can do whichever cross you want. It doesn't matter which cross you do, but I went after the variable. Wherever the variable was, I went after that first because then my variable's on the left, and that makes people happy when the variable's on the left. And then I went this way. 7 times 48. For most people, their problems are over with proportions once they get that far, because like, okay, I know what to do now. Multiply the 7 and the 48, and you get 336 after typing it into your calculator. And then final step, divide both sides by the 12. And 336 divided by 12 is 28. How'd I do? Is there a calculator person out there double checking? Let me see, Mr. We're good. Now, a couple of things. The first is, it is possible to do some proportions in less steps than that. I'll admit that. Cross multiply isn't necessarily always the fastest way. It's just nice and repetitive and simple. Second, be prepared for decimals. We're not going to, this is about the last couple of slides where we're going to be just acting like these are going to be nice whole numbers every time. We're preparing for non-decimal numbers. Third, notice cross multiply. Both the first two examples, I put the x in the numerator. Cross multiply is totally prepared for x's in the denominator. It does not care. It's like I can handle x in the denominator. That's where how I did the first one, where thinking of dividing, multiplying, all that kind of stuff, that was where that can get challenging, but cross multiply is like, I got it. So before we carry on, you try C. You can try D as well if you want. Try to cross multiply with C and D and see if you can do it. I'll do C slowly up there and you can compare, and then we'll talk about D. We'll get someone to walk me through it their own way. Don't peek until you've tried it.
Should we do fractions or decimals?
That's a great question. That is a great question. I'm glad you asked that because I'm gonna talk about that. And because it seems like I'm going back and forth. It seems like I'm like all on about fractions, then all of a sudden I just throw a decimal in there. And we really got to get some wisdom there going forward. How'd this one go? Is it okay? And reasonably fast, yes? Now, should we go fractions or decimals? Here's my math wisdom. My math wisdom is stick with fractions unless there's something in the question that indicates you should go decimals. That's my math wisdom. My science wisdom says we're going to be using decimals a lot. It's probably in science class you're going to go to decimals. There's reasons for that. In grade 11, instead of it being 1.5 over x and 2 over 10, it might be something like 1.5 over x and 2 over y. And we got to get used to the idea that we're not just punching these things in our calculator. That's what we're getting ready for. So stick with fractions unless there's some reason to go to decimals. I put the decimal answer there just in case people jump to it. Okay, can someone walk me through this second one, if that all went so well?
Cross multiply 15
Just
by 8.
15 by 8? Did you go 15 by 8 on the left?
I put 10 and x on the left.
He put 10, he did put 10 and x on the left. So he said cross multiply 15 times 8, and he put it over here. Yeah? Good. Put the numbers over there. It just looks tidier. There's nothing wrong with it mathematically, but it just looks tidier. And then the 10x on the left. And again, for most people, once they do cross multiply, they're like, I'm fine now. So 8 times 15, 120. And divide both sides by 10. Let's practice our fractions. 120 over 10, which should be oh, it's just 10, is it? It's not even a fraction. 12, sorry. Did you see me fall asleep there? I totally got distracted. What was I getting distracted by? Oh, I was trying to think about what we're going to have for dinner. Shrimp or fish. Yeah, see what happens? Happens in my brain too. So you gotta, when that happens, you gotta refocus. Thank goodness you were here for me. Is it okay? Okay, now with a new algebraic tool in your holster, now we go back to what we were working on, which was similar triangles. Find the missing side and angle measures. Given triangle ABC, squiggle, squiggle, triangle DEF, squiggle, similar. Boy, key moment. It says these triangles are similar. And your brain is supposed to, at that point, then go, oh, if they're similar, their angles are all the same. And their sides are proportionate. Those are the two things that are similar triangles. It says find the measure angle C. Okay, I'm looking here. C. Oh, this is the angle they want here. This is the question mark right here, C. This is the easy part of similar triangles. Does anyone know what C is? 31. See, that was the easy, that's where we left off with similar triangles. You just match them up and go, okay, 31 degrees. Here's the difficult part. I don't know how difficult it is. You might have to see it once, and you're like, okay, I can do that. You might be after one example, like, okay, see ya. Go sit down, Mr. Todd, I got it, right? It says solve for find measure C. Did that. C equals 31. C equals 31. Got it. Then it says find the length of DE. So this is my other question mark on the question. It wants the length of that side. I'm going to call that side DE. Yes? You see? DE. It goes from D to E. That's the best description of it for this chapter. We might come up with a short form for that next chapter, but for this chapter, that's the best description. DE. How are we going to find DE? There are many ways to do it. Go, tell me. Absolutely. I'm going to show you a tidier way to do what you're saying. Really. And a more powerful way. I'm going to write down the proportions, just like you said. If they're similar, AC over DF, and don't let me away with it, stare at the picture for a while and make sure you agree those are corresponding sides. Whatever you get when you divide AC divided by DF, there's some multiplier there. And look, can you see it's an awkward multiplier? 20.1 divided by 16.1, it's going to be like 1 point yuck. Yes? But I'm just going to write the proportion here. equals AB over DE. Now just really stare at that. This is the whole lesson right here. If you can write that, I swear the rest of this lesson is really straightforward. Really look at that and see if you see that. If you don't, watch this move. I'm going to do that and say AB and DE are like the same sides. And then I'm going to do this. And like AC and DF are the same sides. Now, stay out of trouble. I always go larger over smaller. Every single time you see me do one of these from now until the end of calculus, I always do larger over smaller. That keeps me out of trouble. AC is the larger side, DF's the smaller side. AB is the larger side, DE is the smaller side, because this triangle ABC is the bigger triangle. If you get that, the party's over. How long is AC? 20.1. How long is DF? 16.1. How long is AB? 12.1. How long is DE? I don't know, and I'm okay with that. I'm totally fine with the fact that I don't know what DE is, because that's what I'm trying to find. Yeah, don't get upset when the unknown, future physics people, don't get upset when the unknown is unknown. Yeah, in your equation. That's like, good, got an equation with one unknown, exactly what I want to find. This does what's not how I was saying. What you were saying, this does that, but handles all sorts of situations as well. Okay. Now what? Cross multiply. Yeah, that's why we did that part of the lesson first. Once you set up these proportions, then you can just cross multiply. And I'll do the full cross multiplying, even though sometimes there's shortcuts. Sometimes you might see a faster way than cross multiply. But this time it's 20.1 times DE equals 16.1 times 12.1. Now me personally, I don't multiply out those two things to get another number. I have trust in my calculator. What's that? 20.1 over 16.1, 12.1 over DE. What's that? Oh, sorry, we're not doing degrees. Yeah, that's look at that. Look at how unfortunate that is. 12.1, 121 degrees. Easy to get confused between the two. Good, thank you. And then I personally do this, but you can multiply those if you want. I don't know that this is a big time saver or anything else, but I guess it makes me that I only have to go to my calculator once. I don't have to type something in, get a wrong decimal answer, and then put that in. I just get to here, and then I type it all in. You type it in as well and make sure you get the same thing as me, because we don't want any mistakes in the videos, do we? 16.1 times 12.1 divided by 20.1 equals, I get 9.69. But I'm going to go 9.7 because, as you're going to find out in science class, if the question's in one decimal place, then the answer should be in one decimal place. The rules are more intense than that, actually. But for our purposes, we'll try and match the decimal places to the question. Meters. Meters. Does 9.7 look right? Yes, it does look right to me. It's smaller. Smaller than 12.1. Do you like? Some people really like similar triangles. It's like, da-da, this over this equals this over this, and away you go. Yeah?
I multiplied by 121.
If you see shortcuts here, I would not take them. I would take my method because I'm on a trail here through this chapter and the next chapter of setting up things and cross-multiplying. Setting up things and cross-multiplying. And if you keep doing it that way, I think you'll find it very efficient. But do you have questions here on slide 5 of 7? Okay. The last two examples, just take what you learned last lesson and what you've learned today and put it all into one big question. And in fact, these two questions are it. If we can do these two, the chapter's basically over. Tomorrow it's just word problems. And I know you now have a built-in section of your stomach for word problems. Just like it's actually, they found out that people do have dessert stomachs, by the way. Yes. As soon as you see sugar, your stomach goes, oh, and it actually expands a little bit to go, yeah, I got room for dessert. I don't got room for more vegetables, but I got room for dessert. So I know that when I say word problems, because of last chapter, your stomach goes, word problems. It's not going to be like that. I swear it's not going to be like that. The word problems here are going to be pretty nice. It's like I'm going to give you the equation. That's what it's going to be like. You know the given equation ones? That's what it's going to be like tomorrow. All right. Shut up, Miss Todd. Get the next example out there. Okay, here we go. Okay, this time they didn't say they were similar. It says use opposite angles and similar triangles to find the missing measures. Well, if they're not similar, we're out of luck here. So we first have to prove that they are similar triangles. Then 2 new weapons appear in our holster. You guys play Fortnite? Do you know what I'm talking about? You're walking through the forest and all of a sudden, the shotgun, or whatever it is. Yeah? If we can prove they're similar, we get 2 new weapons. And we'll talk about what those are. Okay, let's prove they're similar. First of all, the easiest part of this question, the easiest part of this question, I'm going to prove that the 90s are the same. Good? Yeah. Excellent. I'm happy. Oh. Yeah. There's opposite angles right in here. So here she wants to do the opposite first. So I say angle HJI equals angle GJF. As they are opposite angles. I like writing the angle on there once I get it. I go over to my diagram and go, I prove they're equal. I'm going to write it on there. Can I write small enough? 43 degrees in there. Yes? Next. This is easy. They're both say 90. Yeah? Technically in the fancy proofs you're supposed to write it, but it seems like duh. I won't write the reason duh. I won't write duh. I'll do better than that, but that's what's going on here. So angle from the center, J, out to the right, and then over equals from the center, J. Good. You just got to look a second to make sure they match up. Those two, and we don't write duh. We write given. It's given. You can see it. It's right there in the picture. They're both 90. That's enough for me. I now know for sure that angle GFJ equals angle, okay, from the 90, H, to the unknown, I, to the center, J. See how I mapped that through? I went, okay, from this angle to that one, to that one. I know those are equal. Do I know they're equal? Because they have to equal 180. And so you can write sum of angles of a triangle theorem. And mathematicians are extremely lazy. Anything that's got a long name like that, you can bet there's a shortcut for it. And you can use the shortcut from here on in. You can use SATT, it's called, whoops. I wrote it too fast. Sum of the angles of a triangle theorem, SATT. Therefore, since all the angles are the same, triangle, let's try and get this right though. Not equal, similar triangle. First triangle, you can do whatever you want in the first triangle. GFJ if you want. Who wants a shot at it though? If it's GFJ, what are the matching up letters to G, F, and J? What matches up with G? H, because those are the 90s. What matches up with F? I, because that's the unknown one, the one that I don't have written in my triangle. And then what matches up with J? J. Does J always match up with J? No, it did here, but let's not assume that that's going to be true. It often is true, depending on the setup of the triangle. Okay. No, there's no O or K. That's part one of these questions. Part one of a lot of these questions is, Hey, prove they're similars first. And it's usually messing around with angles. It's usually parallels or opposites or F pattern or C pattern or something. You mess around with the angles till you prove the two triangles are similar. And then the second part of the question, you look for a side.
Is the SATT similar to the
Angle
angle sum property?
sum property, yes. Yeah, just another name for the same thing. Good. Now, over here, I want GH. So I'm going to put GH. Oh, GH. Goodness gracious. That's some serious stuff to get GH. So I'm not going after GH. I'm going to go after, this is a pretty massive math problem solving technique. I can't get GH. So I'll get what I can do and see if that helps. I think I can get GJ. Yes? I'll go after that first. I'll go after GJ. Then I'll go after JH. Yes? Okay, so. No, I don't think I can get GJ. This must be a misprint. Let me just stare at it for a second. I believe this is a misprint on these new version of these notes because GJ and JH match up and neither of those sides is given. Okay, so I'm going to do, I think they meant to ask FG. Yes? Can we do it? Yes. Next chapter, I will totally be able to handle this. Oh, wait. I see it. I see it. Hold on. Who's got it? Who's got it? Hold on. Let me erase that. I forgot about one weapon here. I now see what it was. Okay. Let's just talk about, yes, tell me. 18.9? Yes? I'm totally with you. And then what did you get? You got this over here, did you? 12.9? Yeah, for this. Okay, so we're going to go after this first. That's going to be my first move, is to go after FJ. But I'm going to do it the way I was showing. Your method, it works great when the numbers are nice. And so I'll do it. Okay. And then after we do this step, I'm going to do what I promised to do, which is I'll do what I can. And then I'll pretend like I'm stuck again, and then somebody can help me out. Okay, ready? Okay, so FG over F to G is I to H. That ratio is the same as FJ over I to J. So, and I have some of these things. FG is a question mark, not upsetting at all, because that's the unknown. That's okay. IH I have 4.3. FJ I have 18.9 over 6.3. And I'm only speaking to Snaha for just a second here. What you're finding is this. You divide to find this and then multiply it over. That's totally fine. Here I'm going to cross multiply because that's what we've been talking about. So 6.3 FG equals 18.9 times 4.3. And then so FG is 18.9 times 4.3 over 6.3, which she's a step ahead of us. She already got that it was 12.9. Do you agree? All right. 12.9. And I forgot about something. After getting that 12.9, I thought that's all we'd be able to do and that we would have no capabilities of finding that third side. What other weapon is out there that I forgot was in the Pythagorean theorem was in the backpack and I forgot? Well, you know what? I didn't forget about the Pythagorean theorem. I forgot that it was a 90. Yeah? That's what I really forgot. I wasn't looking at the picture and noticing that was a 90. It's not isosceles. If it was isosceles, I'd be off to the races. Yeah, if that was a 45, I'd be home free. It's going to be close, but it's not exactly right on. So those of you thinking of getting an iPad for your birthday or for Christmas, let me show you a cute trick that iPad people and me do all the time. And stuff like this, we're like, okay. Eh? Handy stuff. Peter, yes? Yeah. And then I go back to fit to width, and now I can finish this off. I'll do the first one for you, just in case the Pythagorean theorem has stretched back into the recesses of your mind. We'll do the first one together, and then you try the second one, okay? I say JG squared equals 18.9 squared minus 12.9 squared. If I did that too fast for you, then you really want to find out what my brain's thinking about, because I don't think I'm doing anything too complicated there. But if you're not sure about this as I go through it, you should definitely ask me and go, how did you come up with that exactly like that? Anyways, I even like this for you now. See? Only have to go to my calculator once. I like that. By moving the square root over now, I only have to punch it in once. You can do it in separate steps if you want. You do it how you want in the second one. You do the second one your way and make sure you get the same answers as we do. And I don't really care. I'm not marking the Pythagorean theorem. I forgot a squared there. I get 13.8. Did you get 13.8? I like writing them on the picture as I get them. It's very helpful. JG's 13.8. You try right now. I'll do it as well, but you try right now on the little triangle doing Pythagorean theorem.
Oh, 18.
You could do it with similar triangles now too if you wanted. And when that person explains, they'll explain how we're doing it. Well, we'll look at their way and see how it compares to my way. Somebody ready to explain JH? Was it too fast? Oh, you're still working. Too fast. Okay, I'll do 2 steps on my cube to keep me from harassing you. Oh, it's a tough step. I'll only do 1 step, will I? Okay, who's ready to tell me what they wrote down to do the Pythagorean theorem on this part? If you wrote it down different than me, that's fine.
GH equals GJ.
Say it again.
JH equals GJ.
They're not the same. Oh, but did you do like similar triangles? Oh, he went over to similar triangles. I like that. He decided, I don't need Pythagorean theorem again, he says. I did similar triangles. But would anyone do a Pythagorean theorem? Equals what? Okay, so he went JH squared, and he went 6.3 squared minus 4.3 squared. I'm going to try and mess him up on purpose. Why is it subtract? I thought Pythagorean theorem was add.
Because we're trying to find b squared and not.
Yeah, we're going after a side length, not the hypotenuse. Hypotenuse has got to be longest. So if we're going after a different side, we got to do subtract, not add. Some of you are like, I like writing down the formula with add, and then I'll rearrange it. I love that too. I'm just trying to give you some shortcuts here that allow you to do these things a little faster. And this is one new shortcut I'm introducing today, because most of this lesson's not too bad, so I'm trying to add a little bit to it. Only have to type it in our calculator once if we put that square root over there. I'm just going to double check to see if I get the same thing as Chris. I'm sure it is. What did you get, Chris? 4.6, yes? 4. You agree with 4.6? And then we're not done. Now we can actually find GH, because it's equal to JG plus JH, 18.4, 18.4 centimeters. Okay? To me, that's as tough as we can get in this chapter. That's as ugly as it gets. Prove the similarity. Ratio of sides with Pythagorean theorem thrown in just as a little curveball there. Did it say to find that? It never did say to find that. It says find the length of GH. Oh, to find the missing measures. I guess you could interpret that to mean we need that last angle, which is, what was it? 37? 47. By just going 180 minus 90 minus 43. Yeah. I'll be very specific on the assignment. Remember, there's no test for this chapter, just an assignment. I'll be very specific on the assignment about what I'm looking for. Or you can ask me. Okay? Is it okay? You have questions? Is it okay? Okay, that was out as far as we need to go. This one is more down to earth. This one says find the length of AC. It just says find AC. But to do that, we've got to weapon up first by proving these are similar triangles. So here we go. Are they similar? You know what helps me sometimes is to highlight one of them in a slightly different color. So there's the green. And then I'm going to highlight the other one sort of in red. Are we okay? Never seen similar triangles get that many laughs. Does that help? I don't know. Maybe it makes it worse. Maybe only highlighting one, but you got to be able to see the two triangles. So, angle equals angle. Which angles do you want to go after first? There's an easy one.
Angle BAC equals angle BCA.
Angle BAC as BCA. It might be, but I don't know that for sure. It looks isosceles, doesn't it? It really looks isosceles. But if it was isosceles, what else would be on the diagram saying for sure it was isosceles? Yeah, little slashes here and there. And I don't want to put them on to confuse the issue. It certainly looks like it's isosceles, but I don't know that for sure. But what angle is BAC equal to because of the parallel lines there? BEDE. And what's that called? Geez, does anyone have the fancy word for this? Inside the little upside down F pattern there? This is why this chapter is good as an assignment. You can flip back into your notes and find out. Do you see that it's an F? It's an upside down F? Corresponding. Okay, go again. Another pair of angles that's equals. I did BAC. BCA, yes? What's BCA equal to? BED. And that's also corresponding. Those parallel lines really help. Once you got those parallel lines, you're pretty much home. And then finally, angle ABC equals angle DBE. And actually, there's two different answers available here. There's the duh one. It's like, well, they're the same angle. That's when we write given. But you could also write SATT. We've proved two angles are equal. because actually it's similar triangles. There's a theorem out there that says once you've got two angles, you're done. You don't have to actually state the third angle. So I give you that weapon as well. Is that if you don't want to mention the third angle, you don't have to, because once you have two, you're home free. You know the third is the same. But I'm going to use given. But sum of angles of a triangle works. Not even doing that third step works. Therefore, triangle BAC is similar to triangle BDE. Good. First part of the problem is over. And a lot of these similar triangles questions have two parts. First, prove they're similar. Two new weapons appear in your holster. Angles have to be equal. We use that. Proportionate sides. Okay, here we go. BD over BA equals DE over AC. Now stare at the triangle long enough that you prove to yourself I'm not being tricky. BD was the left side of the small triangle, and BA was the left side of the big triangle. DE was the bottom of the small, and AC was the bottom of the big. Mr. Todd, you just broke your rule. You just said you're always going to do big over small. Well, I want to provide freedom to you. It doesn't have to be bigger. That was just the way I handle it in my brain. So, how long is BD? 48. How long is BA? I'll let you think about that for a minute. How long is DE? 36. How long is AC? I really don't. I don't mind that AC is an unknown in that. So how long is BA?
60.
60. Okay, maybe that wasn't that hard. Yeah, but once in a while you get a little overlap there. And then cross multiply. 48 AC equals 36 times 60. And so AC will be 36 times 60 over 48. You can do that in multiple steps. I like only going to my calculator once. So I like rearranging it all and then just type that into my calculator once it's all done. Is it 45? Do you have questions, my friends? Let's be clear what's going to happen now. Tomorrow I'm going to do the same thing with word problems. You're scared. Don't be. I swear it's going to be okay. I swear. I promise. It's going to be okay. And then you have Thursday to work on your assignment. The assignment is not due at the end of Thursday. You just have a work period to get a good start on the assignment. The assignment can be due. We can negotiate that due date. Yes? Then we'll start our next chapter on Friday. Our last chapter on Friday. Exciting. Trigonometry we're starting. Well, this is trigonometry. But well, look at your calculator. Do you see look at these buttons. Maybe you've seen them before. On your calculator, sin, cos, tan. We're going to get to the bottom of what those three buttons do.